Algebra 1, Lesson 86, we are calculating midpoint and the length of which uses a couple different formulas. We use the distance formula, which says that the distance d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. We also are going to be using the midpoint formula, which divides the segment in half, finds that middle point between two, and we use x1 plus x2 divided by 2, and for the y point, y1 plus y2 divided by 2. So that midpoint gives us a new coordinate point that's right in the middle of our 2. So the Pythagorean theorem is what a lot of this is based on. It's not only used for triangles, but often to use when measuring directly is very difficult. So we need to know a couple of the sides in order to find the third. Okay, so let's first look at this figure and say, what is the distance of PQ? Well, in this case, we want to know this diagonal distance that is not perfect because it's not going through perfect squares. But we can say this right triangle that can be formed has side length of 3 because it's 3 blocks by 4, which means we can use the Pythagorean theorem to say 3 squared plus 4 squared equals c squared. So 9 plus 16 is 25 equals c squared. So c must be 5. This is also Pythagorean triple. Okay, so we can use the Pythagorean theorem in order to find some distances that are kind of hard to actually measure. We could also do this with any amount. If we were to do the corner of C Street and 5th, so right here, to the corner of G Street and 1st, right here, we could do something very similar, okay? But in this case, we would have 4 by 4. So we could plug it into the Pythagorean theorem and say 4 squared plus 4 squared equals c squared. So 16 and 16 is 32 equals c squared. And I could take the square root and simplify a little bit. Because I can take the square root of 16 out, I can say that's 4 root 2 equals c squared. And that's how far it would be between those two corners of the streets. We can also do this on a coordinate plane, and the same thing happens, okay? I won't reproduce it here, but the same thing happens. And that's, the Pythagorean theorem really is where we get the formula. If we were to, basically, it reminds us of the Pythagorean theorem because if we were to solve for c squared, if I have a squared plus b squared equals c squared, and I wanted to solve for c, that distance, I would take the square root. So I would say c is equal to the square root of a squared plus b squared. But a and b are actually found by finding the distance between the x values in what we're finding and the distance between the y values that we're finding. Okay? So, for example here, we have this, this line here, and I want to find what is the distance between those points. But unfortunately, they are not on perfect square, so I have to use the distance formula. I can plug in these values and say, I want the square root. Let's see. We have x1 and y1, and we can say this is x2 and y2. It actually doesn't matter how you label them, just be consistent. Okay, so we can say x2 minus x1 is 6 minus 3, and we'll square that, plus the difference in the y, so 4 minus a negative 2 squared. And we can start simplifying. We can say we have the square root of 3 squared, which is 9, plus the square root of, well, 4 minus negative 2 is adding, so we have 6 squared, which is 36, meaning I get the square root of 45, which we can simplify to, well, the square root of 9 is in there, so we have 3 root 5. That's the distance between those 2 points. Okay. We can continue using this just given our 2 points. So let's try it a couple times. I'm going to take the square. This is x1, y1, x2, y2. And until you get really comfortable with this, I would encourage you to write those out. We're going to do 4 minus 2 squared plus negative 3 minus a negative 2 squared. So I say 4 minus 2 squared is 4 plus, well, negative 3 plus 2 is a negative 1 squared, so we just have plus 1, meaning our distance is the square root of 5, which We could just get a decimal equivalent of that, but that's a good, clear answer. All right, we do it again, and we can say 2, or sorry, I started with the y's, so let me change that really quick. We're going to do x1, y1, and x2, y2. So I should actually have 4 here minus a negative 3, and I'm going to square that, and then add to it 2 minus a negative 2. I'll square that. And I'm going to get the square root. Well, 4 minus negative 3 is 7 squared, so that's 49 plus, well, that's 4 squared, so 16. So we end up getting the square root of 65, I believe. All right, and so let's see, the square root of 65, I don't believe that can be simplified anymore. It's really just made up of prime numbers of 5 and 13, so leave it as is. Okay. We can do this even to determine, okay, is a figure like this a rhombus? So we can say, are all of these distances the same? And you can try that for yourself on these two. Taking all of these points, plugging them into the distance formula and saying, okay, if it's a rhombus, all of these side lengths need to be the same. Okay? Now, to go on with the midpoint formula, really we're just trying to find what is the point that's right in the middle of these points. So let's just try it out. It's going to be very similar to doing distance, but we're going to end up with a coordinate point as our answer. So once again, we're going to label x1, y1, x2, y2, and I'm going to plug it into the midpoint formula, saying x1 plus x2, so 3 plus 7, divided by 2. Really, we're finding the average of the x values, comma, y1 plus y2, 5 plus a negative 2 divided by 2, so the average of the y's. And when we end up with 10 divided by 2, which is 5, and 5 plus a negative 2 is 3 divided by 2, so we can have it as 1.5 or 3 over 2, but this is our midpoint. Just plugging in and simplifying. That's all that's happening. And the midpoint truly is what is the average of the x's and the y's. Let's try it just a couple more times. So we have x1, y1, x2, y2, and we're going to do 7 plus 5 divided by 2, and 10 plus a negative 4 divided by 2. We end up with 12 divided by 2 is 6, and 6 divided by 2 is 3. So our midpoint, right in the middle of those two, is at 6, 3. If you were to put it on a coordinate grid, you would see that's right in the middle. Whether they're on a diagonal or not, it's right in the middle of the two. Okay, a couple more. We're going to do negative 2 plus 4 divided by 2, and 3 plus 7 divided by 2. We end up with 2 divided by 2, which is 1, and 10 divided by 2, which is 5. So our midpoint is 1, 5. Alright, so we can do this in certain contexts as well. So in order to model players on a football field, coordinates played. The quarterback is on the 30-yard line, 30, 10, and he throws to a receiver who's on the 50-yard line, 50, 40, find the length of the pass in the simplest form. Then estimate that length to the nearest yard. So what we're trying to find is the distance. So if I have x1, y1, x2, y2, I plug it into my distance formula to say, all right, x2 minus x1, so 50 minus 30, we're going to square that, plus 40 minus 10 squared. We start simplifying. We say we have 20 squared plus 30 squared equals the square root of 400 plus 900, which gives me 1300, okay, which we can put it in simplest form.